Right, now let us slowly move it to complicated signals as a next example, which is very important. Okay, so let us take x of t to be equal to e power minus at u of t. Okay, so when will Fourier transform of this signal exist? Only if a is greater than 0, correct? But here we are not putting any condition on a. Okay, so we assume a to be real, so it can take a can be negative, a can be positive. Okay, so a can be negative or a can be positive. So what happens, how does the plot look when a is positive here? Let's say a is positive, let's say 1, so it looks like e power minus t u of t, so which is exponentially decaying function. Okay, so this is the plot of x of t. This is e power minus at, and this is the case when a is greater than 0. Similarly, how does the plot of this function look when a is less than 0? When a is less than 0, let us say a to be minus 1, I'll get e power t. So e power t is exponentially increasing function. So what is the equation of this curve? It is again e power minus at, don't forget that. But what is the condition on a? A is less than 0. So this is the plot of e power minus at u of t for two cases. What are they? A greater than 0 and a less than 0. When will Fourier transform exist, or for which signal, for which condition Fourier transform exists? Only for first condition Fourier transform exists, but Laplace transform exists for both the conditions. Okay, that is the beauty. Okay, right. Now let us try to find the Laplace transform of this signal. Okay, so what will be our x of s? X of s would be integral, because u of t is there. Integral will be from 0 to infinity e power minus at e power minus st dt. Okay, now let us substitute s with sigma plus j omega. You will get integral 0 to infinity e power minus at e power minus sigma t e power minus j omega t dt. So which is same as integral 0 to infinity e power minus of a plus sigma t multiplied with e power minus j omega t dt. Okay, yes, so by looking at this equation, something should strike. What is that here? Yes, let's assume that a plus sigma is some c. Okay, a plus sigma, let's assume that to be c. So definitely this is nothing but ctft of which signal? E power minus ct u of t, correct? That fellow is looking like ctft of which signal? Ctft of e power minus ct u of t. Everybody okay with that? Correct, it is looking like integral 0 to infinity e power minus ct e power minus j omega t dt. What is that? It is Fourier transform of e power minus ct u of t. When will this exist here? This exists only if this is looking like e power minus at u of t. When will Fourier transform of e power minus at u of t exist? Only if c is greater than 0, correct? Only if c is greater than 0, or what is c? C is nothing but a plus sigma, should be greater than 0, or what is sigma? Sigma is real part of s. So or real part of s should be greater than minus a, correct? So from this we get this condition. Okay, so ctft of e power minus ct u of t exists only if real part of s is greater than minus a. So ctft of e power minus ct u of t exists implies who will exist? X of s exists. X of s exists means what? X of s converges. Okay, so we can say that x of s converges only if real part of s is greater than minus a. Hence we call this as what? Region of convergence of the Laplace transform of the given signal. Okay, right, I repeat, Fourier transform of e power minus ct u of t exists only if c is greater than 0. Indirectly, real part of s should be greater than minus a. So ctft of e power minus ct u of t exists implies who will exist? Our Laplace transform x of s exists. Okay, x of s exists means what? It means it will converge. So when will x of s converge? X of s converges only if this condition is satisfied. Which one? Real part of s greater than minus a, and hence we call this condition as what? Region of convergence. Okay, right. Now let us proceed. If the above condition is satisfied, which one? Here, this condition. Okay, if the above condition is satisfied, okay, if the above condition is satisfied, what will happen? CTFT of e power minus CT u of t exists implies what? X of s exists. That should be equal to, if above condition is satisfied, then what is x of s? X of s is nothing but CTFT of e power minus ct u of t, which is nothing but what is Fourier transform of e power minus ct u of t? It is 1 by c plus j omega. Okay, so that is 1 by c plus j omega, but we know that c is how much? C is nothing but a plus sigma, so you'll get 1 by a plus sigma plus j omega, and this we can write it as 1 by s plus a. Why? Sigma plus j omega is how much? That fellow is yes. Okay, so sigma plus j omega is yes, so we can replace that with yes, and you get x of s to be 1 by s plus a. So what is the region of convergence? Region of convergence would be real part of s greater than minus a. Okay, so let us summarize what we have got. What is it? We have got e power minus a t u of t. We'll have what as Laplace transform? We'll have 1 by s plus a as the Laplace transform with ROC, real part of s greater than minus a. Now let us try to plot this. Okay, so if you try to plot the region of convergence, so once I say plot region of convergence, we should go to S domain. Okay, yes, so definitely the Laplace transform would be infinite at s equal to minus a, so that will not contribute to the region of convergence. Okay, so but we know that s equal to minus a is a pole. Let us assume that first case a is greater than 0. So when a is greater than 0, what happens? S plus a will have a pole, or 1 by s plus a will have a pole at minus a. Correct? So this is our minus a. Okay, yes. So what is region of convergence here? Region of convergence is given to be real part of s greater than minus a. So where is that region? That is greater than minus a, means this region. Okay, so that is the region where our x of s converges. Okay, so note that this is a top view. X of s is 3 dimension, so it looks like this. This is sigma j omega, something like this. This is sigma and j omega, and our x of s will look something like this. Okay, indirectly it means our x of s will sit, or will sit on the sigma j omega plane. Okay, so if you look from top, it looks something like this. Okay, yes, so region of so our x of s would be like, it will have different shape, something like this, we don't know. If you look from top, what is the region that fellow covers? That fellow covers this region. Okay, so this is the top view of x of s, where x of s exists. For in this region, what happens? In this region, our x of s does not exist. Okay, our x of s does not exist. Okay, so this is the case when a is greater than 0. What happens when a is less than 0 here? This is sigma and this is j omega, and again we have a we let's say this is the case when a is less than 0. Okay, so when a is less than 0, what will happen? S plus a means what? A is negative, so definitely s plus a would be positive. So we have a pole at minus a. Okay, because a is negative, minus a would be positive, and hence you have a pole here. So what will be the region of convergence? That is again real part of s greater than minus a. So this is the location of minus a, and greater than minus a would be this region. Okay, that would be the region of convergence for two cases, when a is greater than 0 and when a is less than 0. Okay.